Hi, my name is Ella Bartolomei, and I go to St. John Paul II High School, and my project was how road salt affects roadside plants. So, all plants grow differently from one another, and for example, some plants such as the mung bean or radish can grow as quickly as 3 to 4 weeks, while other plants such as succulents can take months or even years to grow to its fullest potential. Germination is a process in which a plant seed begins to sprout. Germination is extremely important for a plant because without the seed to sprout, the plant would never grow. This process can take as short as 4 to 5 days or as long as 4 to 5 months, depending on the plant. Chlorine, not chlorine, chloride is substitutable in water, which is why it is used in road salt. There are some safe chemicals for plants, though. So one of those safe chemicals is fertilizer, and fertilizers for many plants provides many valuable nutrients to help the plant grow sufficiently. In 2016 to 2018, the global air pollution rate rose 5.5%. The global air pollution rate rose because of the amount of new chemical gases from modern technology and everyday life going into the air or into our environment. So, types of road salt. There are 4 types of road salt: sodium, magnesium, calcium, and potassium chloride, all shown on the side of the screen. Sodium chloride is a rock salt and is most commonly used and available. It's usually white or dark green. In this case, it was white and used with pre-wetting agents. Pre-wetting agents help keep the amount of salt used to a minimum. Magnesium chloride. Magnesium chloride is made by evaporating water in lakes and containing pre-wetting agents. It's not as corrosive and it reduces the dust and dirt on the roads. Calcium chloride. Calcium chloride is a lot similar to magnesium chloride. It's usually found naturally but can also be manufactured. It can dissolve ice at a lower temperature, and the moisture trapping also reduces the amount of dirt and dust on the surface, just like magnesium chloride. This one looks a little different. There's little pellets because they are actually made manufactured, where a lot of the other ones can be found naturally. So this shape is more manufacturable, and the other one is more natural. Potassium chloride. Potassium chloride is found as granules, just like the salt on your table, and it's found in white or red, and it's not effective with low temperatures and usually mixed with other materials in order to have an effect. Because it's not really usable for lower temperatures, it's not really used on roads. Experimental design. So, questions and hypotheses. Is road salt toxic to plant life, and at what amount? My prediction for that was that the more road salt that's added to plants, the more toxic it will be and the plant growth will be unnoticeable. My other question is, if table salt is used to preserve foods, why does road salt melt away the ice instead of preserving it? A quicker death of the plant would be likely due to the unnatural chemicals used in the salt that has not been proven as a good fertilizer. Most road salts are not real salt purely, or the kind of salt that you put in your food, but also mixed with others and mixed with chemicals. So that's why when you put road salt on the roads, it doesn't preserve things. And the things that salt preserves, table salt preserves, usually don't contain a lot of water like meat. So that's why it's able to preserve it for so long. Materials. So on the side of the screen here, you can see a picture of all my materials. And for the road salt I chose to use sodium chloride because sodium chloride is most commonly found and most commonly used on roads, which is why it made more sense just to use that. Experimental setup. My independent variable was the plant height. Dependent was the amount of salt mixture. So one salt mixture had no salt at all. The other ones had either 1 tablespoon of salt, 3 tablespoons of salt, or 5 tablespoons of salt. My constant variables were the temperature kept, the room temperature that was kept in, the amount of light each plant was given, and the days that the plant were allowed to grow, and the amount of salt and water mixture that each plant was given. And the control was the regular water, the one without any salt, so it was just regular tap water that I was watering the plant with. So part 1 of my procedure was how to make the salt mixture. So every day you measured 1 cup of water and you pour the 1 cup into 3 cups or bowls. So you had 3 cups in total. In the first bowl, you add 1. In the second bowl, you add 3 tablespoons. And in the third bowl, you add 5 tablespoons of the road salt. Part 2 of my procedure was how to conduct the actual experiment after making the mixture. So first you label all the planting pots with a different amount of salt. Then you measure the amount of soil, which were 2 cups that I used because I used mini planting pots. And you put the soil into each pot. You bury the seed about 2 inches into the soil. And every day water the plants with the different salt mixtures, with 2 tablespoons of the mixture being used. Part 2, the seeds will take about 45 days to germinate. That is the amount of time it will take for the control to germinate. This is before the experiment even started that these numbers were given. So this could honestly depend on the salt could definitely impact the germination process. You let the plant grow for about 2 weeks, measuring the height and size of the plant every 3 days. Record your observations and repeat all steps 3 times for more accurate data collection. Results and discussion. So my results here are based off of 3 trial runs and averaged all together. And as you can see, we couldn't even make a chart out of this because the plant with 1 tablespoon, 3 tablespoons, and 5 tablespoons all showed no growth. After 3 trials, none of the salt-treated plants grew. The plants without the salt treatment grew to almost 5 inches. And in the end, they did take 4 to 5 days to germinate, where the other ones weren't even able to germinate. Osmosis was unable to occur through the plant tissues because the mixture that the plant was given was so dense that it couldn't even fit through the tissues. That caused the plant to become dehydrated, not able to take in any water or oxygen, leading to plant death and no growth at all. Conclusions. So there could have been a few errors on not only my part, but just in general. So the way I chose to dissolve the salt was I took it in a shaker and I added the mixture into a shaker and I shook it up until the pieces of road salt were completely dissolved into the water. So it was just one smooth mixture. But there are so many ways you could have done it. You can boil the salt out of it, and the other way you could do is not dissolving it at all and see if that would have been a different effect. And another experiment or other experiments that you could try were, does this way you dissolve the salt affect the way the plant grows? I definitely think that it could change it because like one way or another, I feel like if you had the granules out in the mixture, that'd be so much more difficult to grow the plants. And another new experiment could be testing the different kinds of road salt that you use. So I chose sodium chloride because that was most commonly found, but you could have tried magnesium, all of the other ones to see how it would have affected the plant. This experiment is not only useful to scientists, but it's also useful to people working in agriculture. Certain fertilizers can actually start to damage the plant if they have types of salt in it. This experiment adds on to ideas to stop putting salt on roads because it's damaging our wildlife. It's not only damaging our wildlife, it could be poisoning us because if there's a snowstorm and you put the salt on the roads and the road salt runs off into these plants, we could be digesting these plants and taking in harsh chemicals if this isn't treated. If we find new and safer ways to treat ice on the roads, our world will be so much healthier. And also, when you put road salt on the roads and it runs off into different plants, farmers are losing money, and we have the demand for the plants and vegetables that we want to eat. And if we can't eat them and they can't provide them, then it's really honestly hurting our economy as well. And this is why we're excited. I really hope you enjoyed this presentation. Thank you.